Can you try and do the remaining letters yourself? Try it out and you see how easy it is. In the same way for decryption, we follow a similar process, but now the formula is going to be different. We're going to use the formula cipher letter index minus the key modulus total number of letters. So to decrypt the letter D, all we do is take the cipher letter index, which is 3 from the table. We look at our key, which we know already to be 3 because we use the same key to encrypt and decrypt. And then we take a modulus of the total number of letters, which in this case is 26. So we have 0 modulus 26, and that gives us 0. And so we know that letter D is going to be encoded as letter A. Essentially, it is the reverse of the initial process which we performed. In the same way, to decrypt the letter W, we use the same formula. Cipher letter index, which is what? 22. Key, which is what? 3. Total number of letters, 26. And then we say 19 modulus 26, and that gives us 19. And so therefore we know that the original letter was T, and that all W's will be encoded as T. Now, what are the advantages of the modulo method? First of all, the modulo method is very efficient because it allows for quick calculations without needing a lookup table and by using just a simple mathematical formula. Also, it scales better and is easier to handle with computer code. Finally, it is flexible and you can use it for all different types of alphabets and even those alphabets that have unusual or specialized values, as such as like the kind of things you find in the ASCII table. If you don't know about the ASCII table, you can Google it and you'll get more information about that. Now, what are the problems with Caesar's cipher? First of all, Caesar's cipher has limited key space, especially when you are using normal alphabets. And that means that you can only shift the alphabet 25 different possible shifts, 25 different variations. And that means that with modern day computing, if you try and use all the possible variations of those shifts, you can actually break Caesar's cipher very easily. Another problem with Ceasar'S cipher is the lack of complexity. Since the encryption scheme only shifts letters without altering the patterns of characters, it is easy to recognize patterns in the ciphertext. And this is because the English language, for instance, has some unique traits. For instance, we know that the alphabet AE, the vowels A, E, I, O, U, occur more in the English language than any other set of numbers. Using this information, one can easily decode the actual meaning in modern day decryption exercises. Another reason or another problem with Caesar's cipher is that it is vulnerable to frequency analysis. And frequency analysis is exactly what we described earlier, where we have said that different numbers appear more often than others. So if I take a letter A and I know that A appears 70% of the time or 50% of the time, I check to see which letter of the decryption appears 50% of the time, and therefore use that to determine the likelihood that that particular word is A. These and other strategies have been used to decode Caesar's cipher in modern time. But Caesar's cipher is a very important concept in introducing encryption and decryption to students who are new to the field.